Morning. Yes, I'm wearing the t-shirt for a bet, thanks. Right. So, thank you is my first thing to say to you guys. Thank you for coming. I know that this is taking time out of your day to come and do this, but you do get an awful lot out of these. That's why I am so keen to support them. Also, thank you to Jane, Alaric, Simon, and the rest of them for inviting me to speak. Because as a VMware person, you don't automatically get to come to a VMUG. You have to be invited. I don't know if you know that, because they're separate. Nothing to do with this. It's not like our marketing people can weigh in and go, Joe must do the keynote. You have to be politely invited. So thank you again for inviting me to do this and taking the risk once again to see the year 2014 when Joe Baguley jumped the shark in the VMUG keynote. So for those of you who don't know and haven't, for whom is this their first ever VMUG UK thing? So there's quite, wow, there's a whole bunch of you have no idea about chickens and kittens. Okay. Okay. All right. So my name's Joe Baguley. I'm the Chief Technology Officer for Europe, Middle East, and Africa for VMware. What that means is I fix projectors in board meetings, and I report into our CTO globally, a guy called Ben Fathi, and I have a peer in the States, a guy called Chris Wolf, who used to work at Gartner. Between us, we head up an organization called the Office of the CTO. There's about 90 of us at VMware working on new, exciting, stealthy projects, one of which is something like Eva Rail, which I'll be talking about a bit later on, and many others besides. And then underneath that, there's 5,500 of us who develop the products. We do have another member of the Office of the CTO here today. It's Duncan Epping. He's at the back. He's upset because he's worn a shirt, especially to be smart, like me. And I've turned up in a T-shirt, so you can mock him for wearing a shirt all day if you like. Duncan's a chief technologist in the Office of the CTO based in EMEA, and he's working on various projects to do with architecture and other things. So I think those of you who have been long-term VMUG people will know Duncan anyway. He's much more of a legend and has 1 million times more Twitter followers than I do. So make sure you catch up with him. So what do we do in the Office of the CTO? Why are we here? We have a very, very simple remit. It's supposedly driving thought leadership and accelerating technology leadership. It's not all about chickens and kittens, though I am, for some reason, becoming rather famous for doing chickens and kittens. People get upset when I don't talk about chickens and kittens, so this is it. I've done it. What I want to talk to you about is what's going on at VMware and what's going on in the industry, because you guys know more about our products than, to be fair, most of us do. You tend to know more about when our products are actually being released than necessarily I do, in terms of when the next GA dates are sometimes. So I don't know how you guys find those out, but you do. So there's no way I'm going to stand up here and give you some kind of crappy marketing organized sales pitch standard deck of what's coming next from VMware, okay, because that's not interesting. What I want you guys to understand is what's going on in the heads of us at VMware and how we see the industry and why we're doing what we're doing. Because there is a plan, believe it or not. We don't just randomly invent stuff like vSAN and bring it to market because someone thought it was cool. Actually, that was Duncan, and yes, it was. But no, there's a whole bunch of reasons, and I want to explain to you the reasons why today. I want to take the opportunity to do that. So let me talk to you about marketing. You will hear a lot of people at the moment talk about the third platform, the mobile cloud era, the future world that we're all meant to live and exist in. You'll hear things like bimodal IT and trimodal IT and all these other wonderful terms. And so you'll see a slide like this where they talk about we have steady IT budgets. Budgets have never gone up. IT is always the poor man of the business, and we never get more money to play with more toys. Why not? We should have more toys. But we're heroes because over time IT has continued to deliver better than the previous year because of thanks to Moore's Law, thanks to VMware and its awesome virtualization, thanks to all these other technologies means that we're actually able to deliver more IT than ever before. But it's worse because what's happening is due to the mobile cloud era and selfies, children are now making more demands on our IT than ever before with millions of apps and billions of users, et cetera, et cetera, et cetera. And you'll hear that this is my favorite bit. What leading enterprise customers tell us they need is a self-service infrastructure that conforms to enterprise IT requirements. And my first contention to you is, I don't think I know what enterprise means anymore. I think enterprise is a term that has been horrendously overused. We hear a lot of people talk about enterprise class without actually knowing what enterprise class is. I think what we would know as enterprise IT 15 years ago, 20 years ago, is not the enterprise IT of 2014. It's certainly not the enterprise IT of 2020, which is what we should be building right now. So I would ask you to think again to yourselves and within your organizations, what does enterprise IT actually mean? And then once you've thought about that, we then go, well, how do we bridge this gap? Well, VMware can come to the rescue, and we'll help you by moving the arrow, or moving the needle, to IT at the speed of business. And everyone looks at you and goes, Joe, what does IT at the speed of business actually mean? That's a marketing term. Yeah, it is, right? Okay. But you'll hear me talk. I talked about this about 3 years ago. I look back about business innovating because IT makes it possible. This is the old story of 2-3 years ago. This is the Netflix. This is the Blockbuster story, right? This is the company should be innovating. I've done that one. IT is a differentiator. We know that. What I'd like to focus on now is what goes in that gap. How many of you here work for an IT organization that has an IT strategy document or IT vision statement or anything like that? Some of you must do, yeah, you see, right, okay. You've all seen an IT strategy document or a corporate strategy document at some point. Now, this is with a doff of my cap to Simon Wardley, who some of you may know is a cohort of mine in Cloud Camp. Does a great presentation. If you want to look it up, look up OSCON 2014, Simon Wardley. It's on YouTube. And he talks about strategy. He's actually got strategy as a service, as a web service. You can go in, it'll automatically generate an IT strategy for you. It's quite cool, actually. Have a look. But what he's pointed out is very true. If you look at strategy documents for IT, they're full of words like this. This is what we're going to do. We're going to do it then. We're going to do it in this way. These people are going to do it. We're going to change the world. That's what's going to happen. This is another disruptive technology. It's a disruptive project. It's a disruptive. It's everything. It's what, when, how. What's missing from all of those strategy documents, from everything we do in IT, is one word. Why? Why do you do what you do to computers every day? And don't tell me for the money. Because trust me, if you're in IT for the money, you're totally in the wrong game. Okay? We do it for some other reason. And so you have to think to yourself, what is the reason? Why do we have IT? Why are we doing IT in the first place? And when you think about it, this is exactly the process that we went through at VMware sort of 4 or 5 years ago, and was part of the process of persuading me to join the company. It comes down to a very simple picture. And this is the picture. This is why we're in IT. We're in IT to provide applications. That's what you're there for. Banks in the 1970s didn't suddenly say, do you know what I really need is a mainframe. They didn't. They said we need some way of digitizing what we do to make us faster than our competitors. We need to find a way of doing electronic banking. It just happens that you have to have a mainframe to do that. So we'll get a mainframe. And then that mainframe evolved into client server, evolved into everything else. There's a whole world built around maintaining this tin. And I think, to be honest, we as an industry have forgotten the why. We quite often, I go and talk to CIOs and people in IT departments that forget the reason why they're doing what they're doing. You ask someone what they do. Oh, I'm a server admin. Why? What do you mean, why? It's my job. No, but why do you maintain those servers? What are they for? What do they do? Why is that in your business? So if we then look at that, we then realize, okay, well, here's a cycle that we go around in IT. You start off with doing some analysis in the bottom right-hand corner there. And you do this analysis and you decide, okay, fine. Remember systems analysts? That was the cool term before architect, before consultant, before, I can't remember, and then it was systems analyst was the cool one. You were in like the early 90s, okay, was if you're a systems analyst, you were cool. You go and analyze what people need. You then go and deploy them an application. And then what happens over time is that application generates data either about itself or generates data that it's been collecting as part of it being an app. And then you analyze that data, and then you modify, update, upgrade the app. And if you think about what you do in your daily job, that's what you do. And what you do is you go round that cycle. This is what IT does. We go round this cycle. Now, the challenge is that we've let ourselves be led around this cycle by vendors. So how often do you go around this cycle? Well, for our mail systems, we go around every time Microsoft brings out a new version of Exchange. For our domain controllers, it's every time there's a new version of AD. Actually, for Exchange, it's every other version. Most people sort of went 2003 to 2010, skipped 2007, or went from 2000 to 2007 and skipped 2003, whatever, right? You go in this cycle. Now, the interesting thing is how long that takes. We go around this cycle once every 3, 5 years. And when we do go around this cycle, it takes us 18 months to 2 years to do it. And most of you out there are employed on projects as contractors or as employees or whatever on some project that you're doing right now. Whatever it is, that project has an end. That project is we will be complete in IT when we have finished this project of rolling out X, SAP, ERP, whatever. So if the whole point in being in IT is going around that cycle, what's wrong with that? What's wrong is what enterprise IT has become. Because if you go and look at the people who are really good at going around that cycle, it's Google and Facebook. And do you know how many times or how fast people go around that cycle if you're at Google or Facebook? Multiple times a day. So you think to yourself, how can I compete? When I'm working with organizations with technology that goes around that cycle once every 18 months, then we have an end of project party and we start the next project. When there's people over there going around that cycle multiple times a day. What does that mean? What it means is I don't think you're ever going to be going around that cycle multiple times a day. Because you have to look at Google, Facebook, and the others that are held up as these kind of, poster children of IT. You have to look at them as the Formula One of IT. Now, if you sit here as a driver or owner of a car, yeah, I would love a car that did 200 miles an hour, right? And cornered like it was on rails, an F1 car. But to run an F1 car is incredibly expensive, and you need the best people in the industry, and you need to make sure they're highly paid, and it's a very, very, very competitive industry that's on a knife edge, as Cato and others are finding out. But what's great about Formula One is it pushes boundaries and drives technology down the stack to the common man. So you've got things like ABS, traction control, hybrid power systems, all these things are starting to come down to the common man, to the Gulf, right, from Formula One. So you have to look at those Googles going around this cycle faster than anyone else and think, what's trickling down out of that to me? Well, the first thing to trickle down is big data. Big data, Hadoop, everything there, it was not created in the enterprise. It's not an enterprise technology. It's not enterprise scale. This is Google scale. And this technology wasn't invented by IBM in a lab. It was invented by Google because they had a problem that they just couldn't have a database big enough. I don't know about you, but if any of you ever have played with Oracle or SQL Server, can you imagine running Google on that, right? It's not going to work. You have to invent your own thing, yeah? The RDBMS wasn't going to hack it. And we've all benefited from that, and we're now seeing, the change that's driven down through the rest of the industry. At the same time, they're driving boundaries of scale. I don't know if you noticed, but Amazon last week at their reInvent conference had Intel on stage, where Intel are now actually building a specific processor for Amazon's cloud. You know you're a big-ass hardware buyer when Intel start making chips just for you, right? So we're looking at scale here. We're looking at new ways of doing things well beyond the, I'm going to build a 4-node server cluster. Those technologies are old and dead. I look back at the parallel stuff that I was doing when I was at university, and Christ, it's archaic compared to what's going on now. And then we look at design for failure, this new wonderful Netflix mantra, the Adrian Cockcroft kind of song. But we're seeing design for failure move not only as hardware moves into software, but we're now seeing design for failure in software as well, understanding that software components disappear. So the whole thing's shifted even further up the stack, from just designing for failure in hardware to designing for failure in software. And hence the rise of things like Cloud Foundry and Docker and microservices and other technologies as we look at massive scale. And it's all driven by companies trying to go round this cycle faster than anyone else. Now, I've got a shock for you, and the shock is I'm afraid there's not going to be any more parties. And what I mean by that is there's not going to be any more end-of-project parties. So I sat with the CIO of a major, the new CIO of a major supermarket recently, and we had a conversation around this diagram. And he said, what's the message I need to take to my people? And I said, unfortunately, you're going to have to work out how you take this message to them because it's not a nice message. The message is, there is no end. You hear about things like continuous integration. You hear those terms used about how we now do new, wonderful agile development. When we look at the IT of the future, there will not be the 18-month, 2-year cycles. That's too long. It's too slow. It will be continuous improvement. And continuous improvement means there won't be a, we've finished the Zybot project, which we've been working for 3.5 years, and we're going to have a Zybot project T-shirts made and have a Zybot project party, right? It's not going to happen. It will be continuous improvement, continuous changes. So the problem is, how do you change your mindset to the fact that you're now going to be working in an industry where there is no end? Scary, huh? But it's also fun, because you're continually iterating to the future. Doesn't mean you can have some great steps, and there's some great steps to be had along the way. They're just going to be much, much smaller as we go forward. So when I draw this diagram up on white, the reason I have this is because it's really simple to draw on a whiteboard, on a napkin, on anything, right? It's not because it's anything amazing. It's just a really simple diagram. When I go and talk to CIOs, CTOs about this, and I end up drawing, and I don't do presentations in front of those people, but I'll stand up at some point, I'll draw this diagram and talk about what's going on in IT. What they'll do is they'll start mapping themselves onto these cycles. They'll start saying, oh, well, these guys work as part of that circle. These guys help us deploy applications. These guys help us analyze the applications. These guys help us with data storage management, retention, security, and all the other stuff. And at the end of it, they stand back and they go, where's the infrastructure guys? And you go, it's a good point. I need to talk to you about that one. They aren't there. And there's a reason for that. And that's what we're building at VMware. So what are we building at VMware? Now, you will have seen this slide before, hopefully, if you've been to any VMware presentation in the last 2 years. The foundation for what we call in the software-defined enterprise revolves around applications. The reason we're in IT is for applications. Remember that, okay? And there's 3 types of application. There's probably more. You've got your classic traditional application. It's what friends of mine would call toxic legacy applications, but typically you're talking about your classic 3-tier applications based on some kind of RDBMS and probably some WebSphere and something else in between. Masochistic architecture. And then you've got your modern applications, your scale-out, microservices-built applications, and then maybe there's stuff you're going to be using which will be SaaS-based, which you will have, for definite. Now, underneath that, we are going on a journey. We're going on a journey where we've not only virtualized compute, but we're also virtualizing network and we're virtualizing storage. We're virtualizing network and storage so that we can have one pool of abstracted virtualized infrastructure. That then allows us to provide you what we call the hybrid cloud across public and private. And at the same time, there's a series of policy-based management and automation pieces that you need on top of that around cloud automation, around operations and business, which is all the vRealize stuff you'll hear about, that comes together to build the software-defined data center. And then on top of that, you have what we call our end-user computing business, which is all about managing and delivering securely all content to any device anywhere. But what we're actually doing at VMware, with all this stuff we're doing down here, is we're making this picture look like this. That's the idea. We're trying to make that bottom box go away. We're commoditizing it. We're making it into something that is easy to build, easy to consume, non-differentiating, but something that enables you to do innovation above at speeds that you've never heard of before. We start to make that stuff go away, that stuff simple to consume, on both public and private environments. That means that above that, where you're going around that cycle with applications, there is nothing to stop you spinning around that circle as fast as you want. Because if you look at what stops you spinning around that circle, what stops you deploying that app, is arguments with networking people and storage people and compute people and data center people and security people and people with tinfoil hats on and God knows what else, right? You know, all these people that for some reason think it's their job in IT because someone put them on a course on Six Sigma that means that they've got a process that you have to follow, and if you're even being vaguely innovative, then you've broken their process, so go away and come back with something more boring, and so on and so on and so forth, right? We've all been there, yeah? And you look at those people and you think, what is your job or point in life? Because it seems to be just to stand in my way. I hope your wife loves you. I always like to think in those situations when I've dealt with that, I think back to the Wall with Pink Floyd, with their fat and psychopathic wives would thrash them within inches of their lives. It always gives me some kind of satisfaction when I meet someone like that and think that's what's happening on the back end to that evil teacher. So the problem is, how do we get rid of those people? How do we automate them out of existence? How do we make sure they don't need to exist anymore? And I'm afraid, yes, if you're one of those people, I'm sorry. Okay? This is the therapy. This is the start, right, when you admit that you have a problem. So how do we do that? Well, the first thing is a statement. And this statement has been made many times. But I feel like I didn't say it last year, and I need to reiterate it for you. The software-defined data center, and I have to make sure you understand this, is everything's done in software, okay? The control is entirely done in software. I continued to see new launched companies, which essentially are a converged amalgamation of buzzwords, that will tell you that they have got some new piece of hardware that is the future of your data center. The future of your data center is software, okay? If anyone tries to sell you a software-defined thing, but to get that software-defined thing, you have to buy their specific piece of hardware, they're lying. Okay? It's just a marketing trick to make you buy their tin. The truly software-defined future literally is done in software. So I did some slides recently. I did an offsite for a very, very large TV company for their CIO, for their sort of CIO summit. They're all the top leaders in IT. And I put these slides together, this next set of slides, to try and explain to them simply what's going on. So, imagine a world in 1987 when you cannot buy a hard drive big enough, or fast enough, or resilient enough to meet the needs of your increasingly and excitingly wonderful application. So invented is a technology called RAID, all right? Which is a redundant array of inexpensive disks. Though, to be honest, if you've bought a RAID array in the last 20 years, I think the inexpensive bit's a lie. But let's call them inconsequential. A redundant array of inconsequential disks. There's a new one for you, right? Now, the point there is that you get these disks and you put them together. And then above the top of that, you put a clever layer. Now, that clever layer originally was done in hardware. For those of you who remember back to the Compact 4500 chassis and the RAID controllers we had to put in those, it was a clever layer of hardware on top of that. Ultimately, that's become a clever layer of software. And now most RAID control is done in software. What it means is that you have an obfuscation layer, this sort of opaque layer between the app on top and the service, the storage underneath, that worries about all that stuff for you. So you turn up there and you say, I need some storage, and it goes, yes, what color storage would you like? And you go, that color, and they give it to you, okay? You don't turn up and say, I want to use a Western Digital, green, 32,000, whatever it is, doodah, specs that I don't even know or care about, right? And you have this obfuscation layer that goes on top of that. It's funny, no word of a lie, Sunday morning is homework morning in the Baguley household. I keep protesting that I did all my homework over 25 years ago, but sadly, I don't seem to, their teachers don't get that. I don't understand that. And my youngest 11-year-old daughter, who has to take a Chromebook to her state school, her project was to spec up and build a PC for less than £1,500. I'm thinking, awesome. You know, the Battlefield 4 machine that I could build for 1,500 quid. My God, right? But I then realized that I am about 5 to 10 years behind in the component piece of building PCs, right? I go to look at the GPUs, and I'm like, Christ, look what I mean, this is a nightmare of buying a GPU. I mean, what happened to just having a Creative Lab Sound Blaster card, right? It's just so many choices. And, you know, you look at the choice of the motherboards, the choice of this, the choice of that, and I suddenly realized that, yeah, okay, there's a niche market where people do that. But the rest of the world, which is me, I'm buying MacBook Airs and I'm buying Chromebooks, and at the same time in my home, I've been using the Xbox to play Battlefield 4 because it's easier, because it's simple, and you just install it and it works, right? And so that's my obfuscation layer. I'm the user. I go in. I don't want to go and build and twiddle about with those. Yeah, I'm sure there are people who do that. In fact, we have people at VMware who do that. In fact, there's a sales guy I know who has this most amazing, because he can afford it, this stupid setup involving a pair of £1,500 headphones. Do you know what? I've decided one day when I retire, I'm going to sell high-end audio to stupid people. Mainly salespeople, if I can find them. But, you know, those people exist out there, those edge cases. But the majority of people sit in this, we just need a RAID controller side of things. And the cool thing about the RAID controller is that obfuscation means that when one of these disks fails, no one notices up the top, right? No one using the RAID service actually notices at any point. They don't go, oh, there's a disk failure. It's not like the person running SAP gets paged at 3 a.m. because a disk has failed in the SAN. It doesn't happen that way, right? It's not the point. And so this is the really, really, really simple leap of understanding that I want you to make, okay? Now, I've been trying to lead you up to this by drawing big empty boxes with software-defined data center on them, telling you not to care about things, telling you to buy an Xbox, all this stuff, right? Because this is the moment. Because now I want you to swap in your mind, and to aid it, I'm going to swap it in front of you on the pictures. Those disks for data centers. I know they don't look like data. I couldn't find a picture of a data center. That's a picture of a building. I did actually meet a customer in the 90s that had their data center on, or their server room, on the 18th floor of their office block, which I always thought was rather strange. They had their fireproof safe, they put their backup tapes in the same room on the 18th floor. And they had to have the floor strengthened to put the fireproof safe in the room. And I asked them, you know, is that all right? And he says, well, if there's a big explosion or disaster, it'll be on top. So maybe that's the future. Now, across the top of that, I'm not going to put a RAID controller. I'm going to put something called the software-defined data center, which ultimately, our secret plan the whole time, right, is not the software-defined data center. It's an operating system for data centers. We're trying to build one layer that sits across the top of multiple physical locations, turns those physical locations into faceless, I don't care what's in them, bits of kit, like the hard drives in a RAID array. And you turn up with your applications to this layer, this operating system for the enterprise, for data centers, whatever you want to call it. And then when one of those data centers fails, no one notices. That's the point. This is how, for example, people like Google work, and others. They built a bespoke system that does this. And so the idea should be that you shouldn't even get a page if the data center fails on a Saturday night. What will happen is you're walking on Monday morning and someone will go, oh yeah, the data center in Manchester failed at the weekend. Oh right, okay, what's going on with that? Oh, well, Dave's going to go and have a look at it. Because it's not a problem, because it's been designed for at a massive scale. And so that is why we have things like vSAN and NSX. That is why we're building these components that we're building, because we're trying to build that one layer that sits across everything. Long-distance vMotion in vSphere 6, where we're going. So vCloud Air, right? Is it just called Air because it's alphabetically ahead of AWS and Azure? This is the first question you need to ask yourself. Why was VMware so late in launching vCloud Air? Well, because it's part of this picture. What we're not trying to build in vCloud Air is the future destination for everything you do. What we're trying to build in vCloud Air is giving you another thing to put underneath that line of the software-defined data center, the operating system data, just something else you can plug in there at will that is exactly the same as what you're running on site, that you can use the same as, you know, it's almost one seamless piece of kit. Physical location and ownership doesn't matter. And so that's why when you look at vCloud Air, we have this thing, it's the same management, it's the same networking, it's the same security. And we're seeing people use it in a couple of ways already, where people are using it to move disaster recovery out to the public cloud, to vCloud Air. We have a bit of a problem because it was called vCloud Hybrid Service, so vCloud Hybrid Service Disaster Recovery, VCHS Disaster Recovery. We then renamed vCloud Hybrid Service vCloud Air, so we now have vCloud Air Disaster Recovery. I'm not sure who we're going to get phone calls from, to be honest, but we have to be careful. I think it's a bit of a strange one there. But we are seeing a lot of people do that. What you do is you pay for DR, and people actually use it as a DR destination. We've had some customers who've spun up to do a DR test and realized that their stuff runs better in our data center than it does in theirs, and have actually switched it round, which is kind of cool. It's good marketing, I suppose. And at the same time, you've got the ability for people to have somewhere they can go and build out new stuff and then bring it back to the private cloud when it's running and when it's at its optimal. Because on the left-hand side, there on premises, you have your data center running in one of two states: underutilized and wasting money, or capacity managed within an inch of its life, which is the best way to run it, right? Now, we all try to capacity manage to within an inch of our lives, our systems, but we never quite get there. But if you've got the ability to have one seamless layer that sits across the top and automatically manages that and makes sure that this stuff here is capacity managed within an inch of its life, and if we need more, we go and use that one, then it's possible. And you can start to get cost-optimal models. But you need some really clever stuff on top to make that happen, and that's what we're building. So ultimately, as we go forward, the software-defined data center isn't just about some marketing term. It's not just we've invented some cool way of making you, buy some more software from VMware. We're building something really, really quite important here. We are democratizing the kind of stuff that you see Google and others using at scale in public clouds. We are bringing it to you as an off-the-shelf commodity item. And over the next few years, you will see us automate and obfuscate more and more stuff that you today will care about and do sessions on. But ultimately, I want you to think of a different future where infrastructure is seen as code. Okay? Now, some of you may recognize what scene that really, really bad resolution GIF is from. It's the best one I could find. Okay? But it's a seminal moment in the Matrix where suddenly Neo realizes that everything he's looking at is just software, and he can manipulate it at will. And for me, that kind of is what we're talking about at the software-defined data center. That point where you realize that all the infrastructure that you have at your fingertips truly is at your fingertips and entirely able to be manipulated in code. Now, I had a meeting again with the CTO of a massive Italian bank the other week, and he told me that every single one of his architects has to be able to code. If they can't code, then they're not useful to him going forward as architects for the bank. Because as he said to me, he does not have a compiler for PowerPoint, right? Or for Visio. He wants people that can go out there and make things happen and make things happen fast. So infrastructure as code is the future you're looking at. And so that's why when you look at NSX, what we're doing when we move all these pieces, the slides sort of played through at speed from before, of all those layer 3 to 7 services, be it switching, routing, security, load balancing, when all that stuff is moving up into the hypervisor, again, we're taking apart those individual discrete components and making them part of the machine. We're moving them up in there. With vSAN, again, we're taking apart those things that were done by specific hardware, and we're moving them up to be part of the machine, to be part of the operating system of the data center. So think about it this way. At the moment, some of you may be networking specialists. In 5 years' time, being a networking specialist in a data center is going to be as niche as being someone right now that is a specialist on how the components interact on the bus within my computer. Because the network of the data into the future will be the equivalent of the bus that you have in a modern computer. And I don't know about you, but I don't get involved heavily in that. Because that's what I look at the operating system to do for me, because I trust them to do that in an automated fashion. That's where we're going. That's the point. So all of these services are moving up to be done in software because when they suddenly get to a scale and a speed that is beyond human comprehension, that's when you need software to do the job for you. That's the world we're heading towards. And you will recall the white box that I put up here last year for the first time. That white box world is becoming a reality, in part thanks to VMware. Now that you guys have found out what Project Marvin, Project Mystic, Project whatever we called it that week, has finally, Starburst, you name it, has finally become, Duncan's smiling at Starburst, has become Evo Rail. You realize what we were doing. So to get to the SDDC, there's 3 ways. You can take all your existing infrastructure and build your own, which a lot of our customers have done. It's the only way to do it. And very successfully, they have too, and we have a lot of expertise in doing that. But over time, you'll see that become increasingly commoditized. The vBlock, or the ANS FlexPod, or whatever you want to call it, that converged infrastructure, it's still traditional stuff. It's still traditional storage, traditional networking, traditional compute. But it's supplied from a hardware perspective in one integrated box. I've seen a lot of people who've tried to build their own vBlock, right? They call it the W block, or the whatever the letter at the beginning of their company is block, right? They try and build one. And then they come back to me 18 months later and go, that's really hard to build one of those blocks. And you go, yes, it is. They said, yes, really difficult to try and get all the firmware versions to tie up. And they go, yeah, that's what those guys do. That's what you're paying them for. So the next step from that is Eva Rail and Eva Rack, which is hyper-converged infrastructure, where everything is done in software. The compute, networking, and storage is done in software, and it truly is white box infrastructure. And so the Evo family that we're launching with Evo Rail and Evo Rack give you that. For those of you who don't know what Evo Rail is, it is a 2U 4-node appliance. And that 2U 4-node appliance will support several hundred VMs. But the interesting thing about it is the configuration model. The spec for the project, and if you want to know everything there ever is to know about Evo Rail, the man to ask is here, Duncan, if you can find him, because he worked on that project from start to finish. The spec was that it has to be from when you turn it on to when you can actually run your first VM and configure your first VM. The spec was it had to be 15 minutes. Okay? Now, can you imagine that with your current infrastructure, project plans, and everything else? Yes, I'll get it running in 15. No, it's not going to happen. It does. Trust me. We shocked hardware companies when we showed them what we'd done with this appliance. At VMworld, we had a Configure Up Evo competition where people who'd never even seen one before would come and play with it. One of them, we got someone who worked in marketing, who'd never actually used anything in a server data center before to come and do it. They did it in 18 minutes. All right? The first one, they had the keyboard upside down for the first 5 minutes. And didn't know where the crayons went, but apart from that, it was fine. But the point here being that the nice thing about this is once you've racked up one of these devices, within 15 minutes, you're running VMs. And people then ask us, I did the session at VMworld on this, and the first question you get is, but can you manage it with vCenter? And you go, yes, you can, but why would you? That's the point, you don't, okay? Rack the next one up. The first one goes, oh, you've just plugged in another appliance. Do you want to add it to the existing pool? Yes or no? Yes. Done. Sit back, 6 minutes later, script finished. You've now expanded your ability to run VMs. Cool, huh? Now, some of you are going, but that's my job. Who's kind of doing that? Well, sorry, but here's what's happening, okay? And don't say I didn't warn you. Evo Rack, guess what? It's a rack, okay? It's a big one. And instead of like Evo Rail, which comes with vSAN, VCNS, ESX, and Log Insight, Evo Rack will come with the full SDDC suite. It will come with VCAC and all those pieces on top as well. Okay? Now, the fun thing is that we have a whole bunch of people that sell these now. This isn't us just coming up with a great idea. The nice thing is we defined an appliance standard in Evo Rail that we have 8 hardware vendors, including some you probably wouldn't think, like HDS and EMC even, standing up to sell you these appliances. And all the appliances are the same. So I said, well, why would all these companies want to sell these appliances that are all the same as everyone else's appliances? Well, theirs are different colors. No. Actually, they're going to differentiate on service. You buy from HP because you like HP, because they provide you machines that and support that you like, so you buy from them. They realize that this is what's happening in the industry. If they don't get behind it, they're going to miss out on the opportunity to be part of your future and part of your IT life. And that's exactly why they're lining up to do this. And when's it available? Pretty much about now. You should start talking to these companies and asking them when you can get hold of your first Evo Rail appliance to play with. So we are building this foundation for the software-defined enterprise. We're trying to make that box in the middle go invisible. We're trying to make it as easy as possible to rack up all those pieces, stack them up, Lego blocks, far away, get on and focus on doing stuff with applications. And then along from the side of that comes a bunch of people who decide that they've got this amazing new thing called containers that no one's ever heard about. And they're like shipping containers. Anyone who's been to VMUG 4 years ago will remember I did a presentation about shipping containers back then, right? And they'll tell you that you don't need VMs anymore because we've now got Docker. It's the future, okay? Well, let's put this into some perspective. Docker is LXC containers. It's containers on Linux. It's operating system level virtualization, if you want to look at it that way. It's the same as Parallels Virtuoso kind of stuff. It's the same as Solaris Zones. It's the same as VM from IBM on the mainframe, right? Essentially, you're virtualizing at the operating system level. All that's new about Docker is the fact they've come up with a really cool way of packaging these things, and they've made it available and attractive to an open source developer market and made a big repository of these things to run it on. Now, the challenge is that people originally went, oh, containers, it's the new VM. Oh, you do physical VMs? Oh, God, you're retarded, right? You know, seriously. I've done panels for a year now where I'm the old guy, right? And there's a guy on stage with a better beard than mine, right? Going full hipster, yeah, because he's a container Dockers dude. And within the first 3 minutes, we both sit there and go, this is not a debate. This is just another workload that runs on top of the software-defined data center that you're building that happens to run on virtual machines. Because where does everyone run their Docker stuff at the moment? Either on top of our VMs or somewhere in Amazon, which is on a virtualized machine. Right? So yes, you might think running them on bare metal, if you're some kind of masochistic purist, is the best way to run Dockers, but it really isn't. Okay? It's just another workload that sits on top of, alongside all the other workloads. And so to underline that, we got on to stand on stage with the CEO of Docker, a guy called Ben Golub at VMworld, sorry, and say that. And at the same time, we've announced partnerships with both Google and Pivotal to help develop features and functions within our environment to make Docker better for us. And there's a few guys here from VMware that are part of sort of the project looking at how we can help support Docker and things like that. So if you want to get involved in that a bit more, come and see me during the day, and I'll point you in the direction of people like Andy and Robbie, et cetera, that can help you if you're having people come and talk to you about Docker in your world. But our plan here is containers without compromise. The point being, to back this up, that we have a project that we did in the Office of the CTO in terms of performance tuning and running some incredibly high-level tests on both Docker and running things natively. So you get a particular Java workload, for example, or a stream workload, and there's 4 charts there. The first chart, you won't see any of these at the back, right? But the point is they're all about the same. It makes no difference, right? Whether the first bar on any of those is running the Java natively on the machine, the second one is running it on a VM on that machine, the third one is running it on Docker in that machine, and the fourth one is running it on Docker in a VM on that machine. All the same, right? Within 0.1, or 0.01, sorry, of performance in either way. Doesn't make a difference, because we're making optimizations to do that. And we're looking at some of the other technology you'll see, speak to the EUC guys about things like VM Fork and Project Fargo, which is the ability to fork VMs while they're running in real time, quiesce a base VM, and fork that VM such that you're cloning everything, including memory. And from that point on, everything written as a diff means you can spin up instances incredibly fast. Forget linked clones or snapshots. This is literally snapshotting a running VM, including its entire stack, in a fraction of a second, and having the ability to have hundreds of VMs as clones of the original one. We're using that initially for desktops. You'll see that in line with some of the stuff we're doing with app volumes. But longer term, you'll see us doing that on the server side as well. So imagine that. Get your VMs and say, can I have 50 of those? Click. Done. It's that simple. It's quite cool. OpenStack. Last thing. We announced at VMworld this year, VMware integrated OpenStack. You can get OpenStack from VMware. That's it. Basically, what you've got is the ability there to either run a pure vanilla OpenStack from VMware or add an OpenStack API on top of your existing vCloud that you've built already. So you've got those people come to you and say, I really want an OpenStack API to talk to your VMware things retarded and old. You go, no, there you go, OpenStack API, shut up. Okay? That's the point of this thing. So as we wrap up here, and I'm delighting my audience by finishing early as usual. I am, as you will check your watches. Ask yourself a couple of questions again. Last year, I asked you to go away and think about how your world is going to change with the world of white boxes. You'll notice back on that slide there were things like Net 1. Who the hell are Net 1? You'll find out. Okay? How are you going to work? How are you going to live in a world where it's all white boxes? But more importantly, how are you going to help your organization go round that cycle just a little bit quicker next week? And a little bit quicker the week after that, and a little bit quicker a week after that. How are you going to dig through and remove the barriers and optimize and commoditize IT to make that faster than ever before? So with that, I thank you very much for listening. I encourage you to spend today going to as many sessions as you can, talking to as many people as you can. This is possibly VMUG, to be honest, is definitely the best community event I've ever been involved in. And I'm doing the equivalent of this in the Nordics in 2 days, as is Chris and a few others. We're all heading off to do this on Thursday in Copenhagen, which is decidedly colder and more depressing than Birmingham, if there is such a place. But yeah, thank you for coming. Thank you for giving your time. Thank you for making this one of the biggest VMUGs in the world. And go and enjoy the coffee break, and I'll see you downstairs. Cheers.